All right, so we're going to have a fun conversation today. We have two people with us who we just discovered their work, but it feels like they've been doing a lot of the same investigations and the same search for truth that we have been doing on A Neighbor's Choice. So we're going to have a very fruitful conversation. And that's because the hosts of the DemystifySci Podcast join us, Shilo and Anastasia. How you doing?
Really good. Thanks for having us.
And we have, because we're doing a science show, we have our chief science advisor, physicist, Dr. Yu. How you doing?
Thank you for having me. I'm doing very well. Yeah.
Now I got to tell you guys, we like all the things that your show's about is just really right up our alley. Our whole premise of the show is that the problem we have in our society is this toxic zero-sum mindset that basically directs us into a cul-de-sac of politics where we're always doing blame games. We're always doing scapegoating. No one's actually trying to solve problems to actually shift us out of what I think to be a kind of unnecessary dark age in terms of the world of physical innovation. We have a lot of innovation in terms of what's going on apps. There's an app for everything to make you look at the phone longer. But as Peter Thiel has said, we look at our newest iPhones while our subways are dilapidated and decaying from the 1960s. So there's something going on, in my opinion, that has redirected our resources away from this kind of mindset we had at the earlier part of the last century, where people believed we'd have jets and flying cars and all these great abilities to revive the desert and turn places back into an oasis. We thought we'd have cures of diseases right under our noses that would be so inexpensive and so non-intrusive. None of that really has panned out in a mass way. And yet, we're still believing that we've kind of reached the end of history as it relates to our sacred cows of knowledge. I happen to believe that the problem we have is scientism and this kind of priestly caste of science that has kind of created all of this unnecessary blockage for disruptive innovation that is human-centered and like ethically oriented. And I think the holy of holies of scientism is physics. And I think that's where, and I happen to associate the problem of why physics, and I know there's a lot of components here, and you guys have worked in scientific backgrounds, so I want to get you to weigh in. But I happen to believe that we are suffering what I call the Mowgli Effect of physics, where whoever captures the world-destroying fire, and that is the atomic bomb, whatever theories that were ascended at that time become kind of enshrined in the untouchable glass that can't be touched, as if, we're going to dogmatize these theories and say this is not to be questioned, not to be challenged, because any kind of priestly caste that can destroy the world over with their knowledge should be treated like religion rather than scientific inquiry. So that's kind of my big picture view of the kind of societal sense of things. So I wanted to get your, kind of perspective on that, and also how you came about developing your podcast.
It's a big question.
Yeah, you opened a bunch of cans of worms there. They're all issues that we deal with a lot with our work and our podcast and all the projects that we're wrapped up in. I think there's a few pieces of the puzzle that do lend themselves towards a new dark age if we're not careful. One of them is the confusion of ideas and physical objects. So something like software versus hardware, which we can circle back on. And the other is the confusion of science with technology. And these two confusions, if we're not careful, can lead us into an endless spiral of chasing our own tail with different ventures.
Yeah, and I think that that's kind of why we started this project, is that we just saw a lot of people that were really confused. People operate in the world because they have a path that is kind of prescribed for them. Like, I think that there's a lot of people that go into the sciences because they kind of figure that they're going to do experiments and maybe they'll get a Nobel Prize one day. It's this kind of like almost half-aware process by which they end up in these places, and all of a sudden they wake up, they're in their 30s, and realize that what they're doing more is writing grants and being preoccupied with the day-to-day process of maintaining the system than they are with this, you know, magical sense that they had when they went in, where they would end up like Darwin on the HMS Beagle, taking stock of all of the different kinds of birds on all these islands and then coming up with these crazy theories. It's like, it's really far away from the promise of what it is to be a scientist, which is kind of innovative and breaking trends and being curious. And we're trying to recreate that emotional space for people that are curious.
Yeah, you guys kind of go to that. I saw some of your graphics and design is like the old-fashioned science shows of our childhood, and you kind of have the puppet show going on. Are you guys still doing the puppets? That was pretty cool.
No, we are not. The puppets were, we were really worried at the beginning about showing our faces while also saying that a lot of science deserved to be revamped. Yeah. And so Shilo one day was like, we should make puppets and we'll puppet. And I was like, that's a terrible idea. I don't know how to puppet. And Shilo was like, no, it's gonna be great. And so Shilo dragged me kicking and screaming into the world of the puppets. And then it worked for a while, but one of our science mentors, this guy named Pierre-Marie Robitaille, who does a lot of work on the liquid sun, he sat us down and he was like, you can't keep doing this. You cannot keep doing the puppets. This is not good. Stop it. And so we stopped.
I kind of have that being pulled in two directions aspect to myself, as I moonlight in the professional wrestling world as a lounge singer. And, you know, I happen to believe that you can pursue, you know, we do a lot on anthropology and physics and all these big topics, but sometimes you just got to have a little fun too. And I think a lot of people in society, and there's a good reason for some reason, but a lot of people say you have to pick one thing and stay in your lane and that's it. I don't think that's necessarily the case though, you know? I think we need more polymath, or, you know, people that are willing to do, you know, play outside of the lines and outside of the divisions that we've constructed.
It's really funny that you say that. Shilo's always talking, what was that guy's name? Young?
Oh, Thomas Young?
Yeah.
Yeah.
As the quintessential polymath.
Yeah, I mean, science is full of outsiders. Look, like, you don't usually see paradigm shifts coming from within a really strict discipline because you need an outsider perspective to really see where things are breaking down. And if you've inherited a whole laundry list of assumptions from your mentor and from their mentor and so on and so forth, you have a tendency to get lost in the details as opposed to seeing the bigger picture. So guys like, you know, the most famous paradigm shifters of all times, from Copernicus to Darwin, we already mentioned, you know, these people weren't within the discipline that they ended up shifting. They were far outside of it. So,
but it's also, you have to recognize that it's a position that gets a tremendous amount of anger directed towards it. Right? I think that we run across this all the time. We talk to people that are trying to upend paradigms and shift the way that we think about any topic, whether it's biology or chemistry or physics. And they're kind of annoyed and a little bit indignant that people are so mean to them about their paradigm-breaking ideas. But you go back through history, and it's just every single person that's proposed an idea has been knocked around by the establishment, has been told that they're the dumbest piece of dirt that's ever been around. And it doesn't matter if they're brilliant, it doesn't matter if they're discovering, you know...
Well, with Thomas Young, like, you know, father of essentially the wave theory of light, as far as we really recognize it today, like there's these blistering pieces in the London Times from his day where they're... Was it the Edinburgh Times? Yeah. Okay. Where they're just railing against him about how dare you challenge Newton, like you're just he was a physician at the time. But ultimately just this brilliant man who actually did understand how light worked better than the people who came before him and the people who were at the top of the academy at the time. And he's just getting ripped apart, just the most searing, mean things, the same stuff you see today about outsider scientists. So like a huge part of our philosophy since the beginning has been, hey, we'll listen to an idea. If you can tell me a story that follows from A to B to C, I really want to hear you out. And so all of our conversations begin with trying to understand what someone's saying. And it's not revolutionary, it's just that we want to be able to steelman people's arguments before we start critiquing any of the underlying assumptions or anything else that goes into it. Let's just hear what's going on. And that's something that I think's been lost, if it was ever around.
Yeah. I think that, you got to be able to, I came across Dr. Yu's work, and we'll let Dr. Yu explain his theory, but it was a serendipitous moment that I encountered his work. So we're going to a evening in the stars at a place in Florida called Bach Tower, which is a garden place in the middle of Florida. And Dr. Yu was the scheduled speaker. And I remember seeing there was a few different events that were going on at the same time in the evening. And we were trying to watch these bats. And I saw this thing, NASA physicist has a theory of everything. I said, well, I got to go see what this is about. And so, I went over there it was standing room only on a Saturday night in a working class Americana city. And people were riveted as a person was holding court and presenting his theory of everything using ordinary physical demonstrations, using jump rope to show wave motion, he always uses props and everything. And I said, wow, this feels like something like from what you see in the movies and you read about the old way science used to be done, where it was something where people would have an event and they would explain things, and that was something really fun about that. And when I was in the audience, and I said, I think I just saw the physical explanation for something that I had been working on, which was a mimetic theory, which is this anthropological theory developed by Rene Girard. I don't know if you're familiar with him. He was a professor out of Stanford University, and he created a theory of everything for social sciences called mimetic theory that explains human desire and conflict and rivalry. His most famous student was Peter Thiel, and he's made a big impact in a lot of Silicon Valley circles as they apply mimetic theory to trying to create business ideas. But I intuitively saw that there must be a physical basis for the social behavior patterns that Rene Girard was describing from a literary standpoint, because of what Dr. Yu said, which was that everything is magnetic. And there's only one particle, one force, one field, one principle, and one universe. I said, I like this. I like simple things. And I like things that even a child can understand. And then I started following Dr. He was so engrossed holding court after his speech with people around him asking him all these questions. And he takes the most amount of time for everybody that asks. He'll spend hours with them. So it's the exact opposite of what society says physicists are supposed to act like. They're supposed to be very rarefied, priestly, and very, I will talk to you, talk to my handler. He didn't have that. He was very humble, and he was in the rush of, in the enthrallment of explaining his discovery. He handed me somebody else's business card. So it took me a while to track him down, but I tracked him down, and I said, I got to learn more about your theory. So we filmed this documentary years ago. This is back in 2016, 2017. And I said, look, because he said he's not going to publish papers in the peer-reviewed journals. And I said, well, if you don't do that, I think the only way they're going to listen to you is if you can predict discoveries and things that could be done that your map of physics says are possible that the current map says not going to happen. So you got to do it the old-fashioned way. Like back when they believed there was a new world, they had maps, and somebody had to get on a chartered boat and go over there and see if they land in the mass that they are predicting, and that's kind of like the old-fashioned way of proving a new paradigm. And so that's how we got it started together. But Dr. Yu, what do you think? What are your thoughts on what we've talked about so far? Anything?
Yes. So David just get you a brief story about when we did met, and since that time, lots of magic things happened. You know, the Bug Tower. I was first time I visited there. I feel like it's a holy place. Somehow I get into the garden, entire environment is different. I can receive some message from supernatural. I feel like entire body react is totally different. Yeah, so I did not expect that kind of response for science. It's a wonderful story, and I do feel like I have, I just came back from NASA that's bring student to work day today. I was supposed to working from 9 to 4. I end up at 3. I start packing and get home probably just like 4:30 something. So David asked me, "Are you tired?" I said, "No, because we have two great guests." I read some kind of a brief bios about you, and all graduate from the one of the top universities and from the physics degree, Mike, right? And also PhD in what is it, microbiology or something. Um, Fantastic. It's all from the Ivy League school. So my question, when I excited, so this is from the system within, right? Come out. So one thing I was always have this kind of concept, say, hey, people from Ivy League school or from so-called elite school in the United States. I'm not sure if in the European too, they always somehow they are doctrinated by certain philosophy. Probably controller is more so than regular universities. So that's my perception. So my question for you: so when do you find the science has mystery? So that's why you want to demystify science. When did you get this idea? So I believe that could be a moment you realize something. So when did you get this? I do have my story, but I want to listen to yours.
I think it was charge, right, Anastasia?
It was charge. So I was studying bacteria, and I was studying the electrical communication of bacteria. And so what happens is that we think about these cells as living by themselves in the world, but bacteria mostly live inside of these complex structures called biofilms that kind of behave more like multicellular organisms. And one of the ways in which they're able to do this communal behavior is that they have these molecules that are electrically sensitive. So you can add charge to this molecule and it'll move through the biofilm to a different area, and then it'll induce genetic changes, and those genetic changes will induce architectural changes in the entire community. And so you have this very dynamic space. And we were studying also metabolism, and all of metabolism is about the movement of charges, right? You're taking sugars and you're taking electrons off of it, and you have the electron transport chain. There's all these free radicals. There's all of these, the NADHs, FADHs, like all of these molecules that do stuff. And all of it is based on the idea that there's charges moving. And I'm like, what is charge? And no one can answer that question. It's like, they can tell you that it's an electron, or they can tell you that it's a proton, and then you're like, okay, well, what's the difference? Like, what gives one a positive charge and what gives one a negative charge? And the attitude is like, that's the dumbest question that you could ask. Like, just do.
They're fundamental quantities, forget about it. And we're like, no, it has to be something that some physical body is doing, right? It's a dynamic concept. So what is going on? What is the atom actually doing? And we were shocked that not only did nobody have the answer, but we were kind of treated like idiots for even asking the question.
Oh, and then Shilo started teaching a summer physics course. And so in preparation for teaching that, we were trying to figure out how to tell all of these stories about light and electricity and magnetism and gravity to, were they undergrads or were they?
They were going into undergraduate. They were like before.
It was
summer
like a
before.
bridge program.
Yeah.
And it's unbelievably difficult, if not impossible, to explain any of these phenomena.
Because one of the things we didn't quite get around to talking about was the difference between ideas, including mathematics, so descriptions of what you see, versus actual mechanics of what's happening, right? And so this brings in the confusion of science and technology too, because the reason everybody is totally happy with the descriptive mathematics for the most part is because it's sufficient for technological progress to a point, right? Whereas, how the actual pieces do their magic is not necessarily interesting when you're just iterating and trying to parameterize the system so you can exploit it for some technological end that you already essentially grasp the basics of anyways, and you're kind of just swapping out pieces. Engineering is a very trial and error based system, whereas science is deeply creative and imaginative. You have to hypothesize, actions by actors you might not be able to see. They had famously, atomic theory goes back for thousands of years, really. People hypothesized that their reality had to be physically constructed of little entities, right? And then we have a very different conception of atoms at this point, but fundamentally, we're looking for stuff we can't see, and we have to be comfortable with that and comfortable with hypotheses. And engineering is not comfortable with hypotheses, right? Like you want that airplane to fly. You don't want to hypothesize it's going to fly. You test it out, make models of it, refine the little pieces of it, and then eventually you come up with a system you can trust. Science is a little trickier because you have to interpret the experimentation you do often, right? Experiment's not going to tell you for sure what's happening, but it will help you rule out things that might get in the way of you understanding that. And so these two methods are actually more different than people realize. And I think that's led to a lot of the confusion. Because look, it's amazing we're manipulating electricity to have this conversation across 1,000 miles right now. But doesn't mean we understand necessarily in those mathematical descriptions what's happening at the atomic level. So it's very subtle, but I think that it's created a great deal of confusion.
And we don't understand, not to go on too much of a tangent here, but Marshall McLuhan, we don't understand the extensions of man and how media technology is extending our concept and relationship with one another as well. So, I mean, this is like we have to kind of pretend to even do a Zoom video with seriousness because of how, these are just representations. This is not, it's not us. I'm staring at a screen with glass, made from some other country. But it's an illusion that we're seeing each other, I guess, in that way.
I mean, I think that just kind of goes to how nascent the experiment of trying to explain things really even is. Like, we've only been doing this for a couple of 100 years.
Yeah.
Like, yeah, the Greeks tried it, but the Greeks were a little loony too.
Yeah.
And so this modern incarnation of it is what? Late 1400s, if you're being really generous. Like, I don't know that we should expect to be super good at it yet.
I happen, hearing Dr. Yu criticizing some of the establishment perspectives on physics along the way, I came up with the word, and I don't know if others have used this word or if it has any meaning, but as it pertains to physics, I said, sounds like they're suffering from what I would call equationism, that everything has to start with this mathematical approach rather than starting incarnationally in the physical world first. And having equations are helpful, but every time I would try to describe Dr. Yu's theory to people who were indoctrinated into the conventional view of physics, they would say, well, I must first see his equations. Have they been published to the priest? Have the priest accepted his equations yet? We cannot talk about this. Well, let's just talk about how things work in the real world. That's what he's doing. He's using demonstrations. No, that's not what physics is. You can't start there. It's not a profane thing like that. You must have equations first, and they have to be approved by other mathematical-oriented folks. And then if they allow, and it sounds like to me, it's a total religious thing. If your dogmatic, dissertation is approved by the priest, you will be allowed to speak to the public about in an official capacity, not as a heretic.
I would go one step further and say that it ends with the equations too.
Yeah.
So, equations are, mathematics in general is a fantastic way to catalog patterns, to describe what's happening in some parametric fashion, which is great. But the idea that you have to actually give some physical explanation to why the equations say what they do, that's kind of been put aside since Newton's time. Newton famously even said, that's not our job. Like, he didn't know what caused gravity. He just knew the equations that described it. And, he went back and appended this piece to his magnum opus at some point where he was like, look, that's not what natural philosophers do. We just put math to this stuff. We think that someday he imagined people would give form to the equations. Somebody would conceive of an explanation, but he couldn't do it. And he sort of excused everybody from having to do that job too. And he's basically a god inside. Speaking of the religion and so the religious aspects of this.
And I don't say that in a pejorative sense. I came at the physics conversation from, again, the mimetic theory journey that I was on from an anthropological perspective. So I looked at it like, oh wow, this has the same social structuring phenomena that I see with every religio, which is what binds us together. Okay, here we are with a very powerful, elite-oriented religio that is at the core of Western identity and all these things. This is very powerful stuff here. You can't just walk in and say, I have a new theory. This just doesn't work that way. And it doesn't really work that way in almost any kind of religio in that sense. And if you join the local, Lions Club, there's people have religious tribal kind of structures and in groups and out groups and scapegoats and heresies, and that's what keeps them in unity together. There's a lot of internecine rivalry going on within these fields, but what binds them together is that they don't allow that. They don't allow those people. Those people are not, and you saw that with the medical stuff. Did you guys have a road to Damascus moment where when it all came to you at once that you needed to found? I mean, you mentioned the concept that nobody had any explanation for charge. Was that your epiphany moment, or was it a series of different things, or another moment?
I mean, it's been a slow burn since then. I think that, charge was the tip of the iceberg, but all the basic atomic phenomena, light, gravity, electricity, magnetism, they all lacked physical explanations. Like, they were very powerful mathematic descriptions of those phenomena, and I mean, I think what really, really fueled us was not that they were mysteries. That's expected, right? That there will be things. We worked in academic research for years, and there was plenty of mysteries that people were working on. What was crazy about this mystery was that not only was nobody working on it, everybody told us to get lost. Like, it was a stupid question. And so that was, I think, what really fired us up. And honestly, it's still pretty fun to this day. And we still work on those mysteries quite a bit. But I think that was kind of what kicked off the party for us. Of course, COVID was a nightmare, but that wasn't really too mysterious to me what was going on. That's kind of a follow the money situation.
I saw you guys got a write up in Business Insider and stuff, and I said you guys must have been you weren't overt with your heresies yet. If you were still getting good coverage.
We had just started, yeah. Like, that was still when I think we were still puppets at that point, still for many years. And it was just, I don't know. I think that for us, it's been this. So, okay, I have this theory, which is that people and social groups have immune systems. And so if you come at physics and you're like, they're all wrong, they're the priest class, we must break the priests and destroy what they've built, they're going to put up a really serious fight. And so my approach is...
Can I just add, and 9 times out of 10 when someone says that, they're trying to replace the priest class with their priest class.
Oh, yeah. Like, Shilo had this amazing experience. He went to go see this guy, Peter Voigt at Columbia, who wrote a blog for a long time called Not Even Wrong. And it was a blog that was criticizing string theory for being super mathematical, unprovable, etc. Shilo had been reading it since he was a kid. And he went into this meeting bright-eyed and bushy-tailed and was like, this guy knows, he understands, and he's going to tell me how it is. And I saw him immediately after the meeting, and he was like, he just wants to replace it with his own mathematical theory. Like, he
Which
doesn't.
is equally impenetrable. And
Yeah. And so it's like, I think that what I realized somewhere along the way is I'm like, it's much more interesting for me to figure out, how did this happen? What are the places in history where things could have gone slightly differently and they didn't? And how is it possible to offer people a jumping off point that lets them think differently in a way that doesn't put them on their guard? Because I think at the end of the day, the goal is to help shift the way that people think about these things.
and open it up for more people to think about it too, right?
Yeah, absolutely. And so I'm just kind of like, yeah, I think that people got lost. I think that people got really preoccupied with their hierarchies. I think that scientism and equationism and all these things definitely took over. But I'm like, I think that it's really a pendulum of history. And I want to not replace that kind of dogmatic thing that was in the previous generations with a dogmatism that points at something else and is like, this is the right way, like,
Yeah.
Our way is the right way. And I'm like, let's have like a little bit of epistemic humility and less
True.
certainty.
I'm very impressed when you mentioned about what is called a charge, electricity, and gravity, magnetism. So these are all fundamental concepts. Actually, from my study in physics and eventually to my discovery, and these are the key questions really we should ask a long time ago. So the lady just asked, so we need to find when in the history and the things started deviating from what we consider as truth, right? And I find when I don't know if you watch the podcast, the PBD podcast interview with Howard, with Terrence Howard, and interview with him and with me as a panel as a guest. You have not watching that one, right? Okay, so that's a good one. So we can start here. So one reason, I'm impressed with your interview with Terrence because your tone and your treatment towards him, right, and the questions and something, very open mind. That's completely contrast to previous Joe Rogan's show, brother Eric Weinstein. Actually, he called me. We talked on the phone, years ago, maybe since 2017, yeah. So he asked me about those things. So I know. So all these fundamental questions have never been questioning. So that means we all know there's something we do not understand physics, but we cannot find out where did it go wrong in physics. So now, if you're watching that video, I made some explanation, but I just summarize here. What I find is the first one is starting from 1785. That's Coulomb's, the French physicist, Coulomb's law. The law is fundamental law in physics. No problem with the law. The description of the law cause confusion. It describes we have two types of charges, one positive, one negative. No problem at all. However, described as carried by two separate particles. So what I believe that might not be the intention. I'm not sure. I did not read the original script of how the French language is translated to, right? I did not read it. But the impression would be you have two type charge, no problem, and carried by two particles seems like no problem. And that, however, that evolved until what is J.J. Thomson, that 1897 discovered electron. Now, the true problem exposed. After J.J. Thomson started from what is the cathode ray test, also discovered electron, right? I believe he spent a couple years before nailed down the term electron which defined as a negative charged particle. Do you remember that moment? Or maybe heard of that one, right? He discovered the electron and named it called a negative charged particle. That's the moment physics started to go wrong. That's what I discovered. So do you have any questions? Because this is the central concept. If we want to do deeper, so where started the things deviate from getting wrong from the reality? So that's the moment. And since this concept is so important, I want you to ask me or something. So you mentioned about charge does not make sense. Where the charge come from? From negative electron, right? Once we have electron, we have a charge. So what is charge? That's something missing from this definition of electron. And I believe he got it wrong. Great scientist, something make a mistake so often, he still contributed. However, there's a simple mistake. Say electron a real particle and carry negative charge. So what happens? So then somebody has to discover, I believe he win Nobel Prize on this. And then somebody else did the similar test, found, hey, I found the particle bending, go through the magnetic field, right? Eject from bending the other word. So that's how we discovered there's a positive charge particle. So then we started testifying we have protons. At least 3 people win Nobel Prize on discovery of protons, and I believe have several people. So if we have a negative charge, positive, somebody discovered neutral charge. So neutrons, several people win Nobel Prize on that one. You see, start with one negative charged particle, and then we manifest it is we have a negative, we have a positive, we have a neutral, and all within one atom. Then how can we make the atom stable with different particles? Then what happens? We started that Niels Bohr extended his academic advisor. I mean, that's Rutherford extended his model. So hey, we have started quantum mechanics model, and so try to match hydrogen light emitter spectrum, right? So that's where I don't want to keep talking there. Do you have any questions about why I said electron is not a negative charge particle? Do you have any questions on that one? Have you ever thought about it?
I mean, I think the word particle is suspect in this discussion from the get-go, right? So what does one mean by a particle? Because, if we are using this Boscovich point particle idea, then we end up with a mathematical artifice that is perhaps missing some important physical pieces. Right. So, I think for ordinary people on the street, they hear the word particle and they think of like a little piece of dust or something like that, which is a statically conceived physical object, right? It has a surface that separates the outside from the inside. It has structure that is essentially based on that boundary. And that is not what a particle of fundamental physics is at all. It's actually a dynamic entity, right? It has some momentum inherent in it. It specifies some activity. It's essentially a listicle of qualities on top of that. So it's really a bundle of information pertaining to some predictable experimental outcome, which is very abstract. So basically, you've made this abstraction a quasi-physical body, even though it's not at all, and then you start performing motion with that idea, which is, what the philosophers would call reification. So you misplace the concreteness of something, and everything gets lost in the chaos after that point. So I think we would identify that being a really important moment as well.
Mm-hmm.
Yes, we should define what is a particle, and I believe Michael just mentioned about it. That's exactly where mathematics hijacked the true physics, deviated from the truth. Just because mathematics have a difficulty to describe finite volume, finite substance mathematically. So they have to treat everything as a single point particle with zero volume. That's the problem. And then once they think that way, because that's the only way mathematics at that time, that's the only tool you mathematics can describe, and mathematics is a very simple raw tools to use. So that's why they started with that. Once they have an equation down, now they use that equation as the foundation of the truth and develop everything on top of it. And that's where get physics wrong, hijacked by mathematics. And the mathematician thinking started only from the equation. Without the equation, they cannot think about anything about the physical world. So that's where things goes wrong. So let's define what is particle. So in my view, just conventional, hey, every matter means something have a substance, not just say measure. Well, we thought, oh, matter has a mass, right? Or measure of the substance. We do have a substance, and the substance do have a volume. Okay, it's not a mathematical single point. Just by that simplification, it's already out of the physics. Get physics out of the equation. So that's the problem. And that's the mathematician's problem. They can only thinking. They're all thinking start from the equation, the symbols of the equation. So that's the problem with them. So since it's true matter, it must have we call the substance, right? Substance has a mass. Mass is a property. We're talking the measure of inertia or something, right? So it must have a physical property, otherwise you cannot make sense of Newton's law, right? So now we have to have a mass. Another thing is our understanding of the matter completely missed out. So okay, first we have a mass. Mass means have a matter. Matter, I mean, it has to have a finite volume. Has volume. So particle has volume. If a particle does not have volume, it's not going to create all the volumes we have now, right? You said we all created by what is infinitesimal volume 0 point and create all the human universe. That's just insane, right? You got it. So now, so that means particle has carry matter, and the matter manifested in mechanical world is mass. So measure the resistance, inertia, right? Yeah, mass. And then have a volume, the third part. So that's entire physics missing. Include what is Damascus, Asian Greeks. The third part is the most
Democritus. You talking about Democritus?
Democritus, yeah. The great prophet. Which is, can you give a guess? What is the part truly we're missing from matter? Can you give a guess? It's a force. Every matter carry force. That's the innate force. That's
what do you mean it carries force? Like, I mean, look, like physical objects can displace one another, essentially, right? You can't have two physical objects in the same place at the same time.
That's right.
But
absolutely.
The only real force is push. Like, I mean, you're just hitting stuff, right? I mean, you can like push against the back side of something, like with fibers, they'll interlock, but it's still just displacement.
That's external interaction. That's not the fundamental field force.
Well, so I'm deeply suspicious of the field concept.
Yes.
And so maybe you can lay out why you think that fields are something separate from measurement of material in motion.
Okay. First of all, let me first answer the questions I have, and then I explain how I define the field. So now we ask all fundamental things. We are talking about the fundamental concept of the atoms, right? Atom has a volume, have a mass. Missing one thing is every atom, every fundamental particle, elementary particle, missing magnetic force, magnetic field force. So now let me define force. The so-called field. The so-called field is something you can influence at any point in space. You can have a non-zero influence, which means magnets can attract some things over distance, right? Can repel some things over distance. So that's a phenomenon itself. A warrant existing of the field means you have an influence on something over distance. So the attraction force and the repulsion force, anything nearby a magnet, if similar magnetic particles nearby magnetic field, so you will have a push or pull, you will have some kind of interaction with it. So that's how I define a field. Means for every space you do have a value. In this case, the physical interaction value is a force. Sure. Interact with. So it's not like I don't know how. So Mike might be able to so how mathematically define those field, which is a different.
I think you defined it correctly. It's a region where every point has a value which is essentially location based. It's right. A vector, generally speaking, a sea of vectors. The question really, fundamentally becomes, what are these vectors describing in terms of the material actors that are acting out the motions that are detected in these predicted or measured vectors, right?
Yeah, so when I say that I'm suspicious of the idea of the field as fundamental, I'm like, if you have a point in space that exerts influence on other things that you put into that space, then there has to be some kind of material interaction. Your field has to be made of something. There's some more fundamental aspect that is required in order to be able to conceptualize the field in a rational way, because otherwise you run the risk of magic, I think.
You ask a very important question. So this is related to what material, what matter, what made of this field. Is that right?
Well,
so we have to have some material interaction.
The field is a dynamic concept, right? It involves motion. So it's something moving, doing something else.
Yes.
Right? The field is not a static concept.
Exactly.
So there must be some invisible actors doing some dance that is accounted for by the description, which we call the field.
So that when you stick your detector in it, it's being affected by the material that is in motion at that place to tell you what the description of that location in space is.
Yes. So if we use instrument measure, nearby magnets, instrument will measure some kind of attraction force or repulsion force, right? Measure something we feel like it's a measure of the object exerting. But I think the field really so in my discovery I found so whenever we have a magnetic magnets, say object there, so we measure fields. So mass interaction with a physical object, right? Without the interaction with the physical, this is pure conceptual, that doesn't count. So what kind of physical objects they are interact with at that particular point? So this made the necessity is we have to have a medium. And the medium are just regular particles, just way, way, way smaller. So smaller, and this particle has to be interact. So that's why if you have anything over space can react, there must be some matter over at that location interact with some objects, right? So it has matter there, and this is I call the electromagnetic medium. And what? So we have a magnet and we have a medium. So that's two different things now. One is bigger objects. One is just like water in ocean. So we have something much finer, smaller matters. Create like an ocean instead of just a magnet. So we do have things. So that's where I started. I started my discovery. Say, hey, what is the smallest particle of matter in this universe? So I said, in order to have a light propagates, light have a light source, right? Light source just like throw a pebble into a pond, initiate initial vibration. So when we see light needed to carried by a medium. So that's why propagates, we can see it. So I said, if we want to know what is the fundamental particle looks like, the fundamental particle must be a constituent of the medium. So what is the particle to make the medium which carry light? That's where I started to make this discovery. So the first property, in order to make a light propagate, number one, so this medium has to be elastic. You know, only elastic system, right? So that means if you make a motion in one area, an elastic medium can carry them due to the connection with the elasticity, right? Can carry this elastic wave moving. So number one, so I said, okay, so the medium has to have an elasticity property. And the second thing is, if we look deeper, what make elasticity? So I believe these questions, Michael, probably you are expert on this. You study what is elasticity of water molecules. Tell me, I have answer, okay, but I want you to tell me what's your answer. What force makes things elastic?
That's more architectural than force-based, right?
Yeah, can we hold that idea for 1 second? I wanted to ask you why you think that the medium is separate from the atoms themselves. Like the object, you said the magnet, there's a magnet which is separate from the medium. And that's a point where I have not been sold on that yet.
David, that's the way academically we study step by step. We have to understand every step. So I like the way you mentioned, but what's the difference between, let's say, magnets made by atoms? We have no problems, right? So what's the difference between medium with atoms? Can we say that? Does that make sense?
I'm curious, yeah, because
the medium does not made by atoms. Let me tell you.
I'm not sure about that myself, personally.
Oh, that's all right.
Made by, and not that the medium is a bunch of atoms, but that the atoms themselves couldn't provide the medium if they had an extended architecture.
Atom itself cannot be. You know, normally what they say, when atom itself is what do you call it, electrical or magnetical is a neutral particle. So the medium is not a magnetic neutral particle. So atoms cannot make this light carrying medium.
To think about this. The way that we tend to think about this is that if you look at the radial distribution function of a hydrogen atom, which is basically...
It's like what gives chemists the shape of the orbitals and so forth, these nice, pretty diagrams.
And it tells you the distribution of the electron, the likelihood that you will find it at any distance from the nucleus. At the nucleus, the likelihood is 0. At like 400 picometers from the nucleus is the maximum of the distribution, and then it falls off. But when you get to the edge of the distribution, it doesn't fall to 0. It approaches 0 and goes off to infinity. And so the way that we've been conceptualizing of all of these phenomena of light, of electricity, and of magnetism, we see the atoms as being part of this rarefied web, where the substance that makes the atom is this material organized into some kind of stable motion, but it has connections that go to the atoms next door and to all of the atoms around it. And so the medium that is the field is these connections of the material that the atoms themselves are made out of, stretching out in between them, so that if there is a photon, so that if there is magnetism, there is electricity, these forces at a distance, it's these extensions of the atom to infinity that are actually providing the carrier of the signal. Because all of these things are just communications between atoms, whether it's gravity or electricity or magnetism or light.
I think that's the part. So you know the problem, but have not find a root problem is deeper than atom, is subatomic particles. It's not atom, deeper than atom. So I can explain. But I believe if you think that way, I believe you may not able to explain even now. Let's make a prediction. Okay, based on your explanation, say, so what's your explanation of charge at this moment?
Yeah, so everybody essentially accepts the radial distribution function of the electron to represent the outer surface of the atom. We're just saying the outer surface of the atom isn't this nice, pretty shell that you get in the textbooks. If you follow the empirically derived math, it's saying that the outer shell of the atom is really furry, actually. It's got some sort of rarefied extensions to it that have to be continuous with the body. And so charge really just represents some motion of that surface material. We like to call the material that the atom is fashioned out of a fiber, so that people don't get confused don't confuse it with point particles. So we avoid the word particle. But the fiber of the atom, the subatomic fiber that the atom is constructed out of, that's in some sort of motion at the surface, which is dynamic. And we believe that the Fermi, essentially the math of spin gives us a reasonable approximation for what exactly that surface is doing. And of course, the projections from the shell of the atom are doing the same motion. And so they're able to convey that same action onto their neighbors, essentially. And so, charge has to do with the relative orientation of the surface motion of the fiber on the atom as it does its spin 1/2 dance, across its surface and into its nucleus ultimately.
Does that really make sense to you? Or
Yeah,
make sense?
Well, I think it's congruent with all the mathematics that I've ever seen.
Right, you are talking about the mathematics, and you are talking about that's exactly the problem of the current physics. So I wanted to make sure.
Just the mathematics that are derived from experimentation, right? It's just a descriptive language for the experiment.
Right,
so
right.
It's always our job afterwards to explain what the equations are telling us, right?
That's right.
Right. So why are these bodies attracted at an inverse square law and so forth, right? And that has to do with their radial distribution of their substance that they're actually fashioned out of.
So I like to ask Anastasia, is that right? I'm not sure if I can pronounce it right. Does that make sense to you? Yeah. Do you understand? He explained what the charge is.
Well, yeah. So I mean, it's like, look. If you have an atom that isn't spherical, it's toroidal, right? So imagine that the entire universe is filled with undifferentiated fiber. It's a sea of fiber that has no structure to it whatsoever. That's where you begin, if you are to begin. And then let's say, and I don't think that this is necessarily possible, but let's say you have a single atom in this sea. What does that single hydrogen atom look like? Well, what it looks like is it looks like a rotational, torsional, involuting motion.
Okay.
And so as the fibers begin to move in a specific way, they move in such a way where they rotate around the circumference once for each involution that takes 720 degrees. So
other way around, but yeah.
720 degrees around the equator and 360 degrees through the interior gives you spin 1/2. And when you have that cohesive motion, you have a difference in positive and negative charge, because it's literally just an oppositional orientation of the motions. Because if you have this torus, the outside of it has to be moving upwards, and the inside of it has to be moving downwards in order for there to be a cohesive flow across the entire surface. And so then you have positive and negative inside of one structure, and the thing that gives you positive or negative is motion. It's direction of motion. And inside of one structure, you'll always have either, like, you can't have the inside of it and the outside of it moving in the same direction, because that just is physically incompatible. It's like, I think actually Weinstein uses this. You know that like weird little toy that's filled with like the mica fluid, and like if the outside is moving up, the inside is moving down, because that's the necessity of the donut organization. And so it makes sense to me. Like when we talk about this, like I don't think that this is the only answer that's available. I think that it is the one that, for me, allows me to see the motion in my mind and to see the orientation of it and to see everything as being networked together. So
charge. So can you give a simple definition now based on all the explanation and understanding? So what is charge?
Charge is the organized motion of the surface of an atom.
Yeah, where like the motion of the surface of one atom with respect to another atom defines its charge. It's really the orientation of that motion. So like a positively charged terminal would be a particular rotational surface of some material whose atoms are facing and rotating in one direction, and the negative would be the opposite.
Okay, so what does your charge different from magnetism?
Yeah, so magnetism would follow naturally because it's the equatorial motion of that same material. It's just the same motion viewed from the equator. Right, so you still have this extended structure of the atom, which is twisting and rotating in this way, but the magnetic effects will naturally occur at the equator at 90 degrees to the electric effects, which are, contact dynamics between atomic surfaces that are actually transmitting, in a line, like a gearbox in a car, sort of.
So what's the origin of magnetism?
Well, the origin in what sense?
Oh, so who produced magnetism? Or how
Atoms.
it was produced, magnetism?
Well, atoms in concerted motion produce magnetism. So it's
So
like if you
the
have a
motion,
magnet.
the
Yes.
motion of atom. So we know the electron is subatomic particles, right? Electron has a charge too, right?
Well, we just agreed, though, that particle is kind of a broken word in this sense.
Because I'm like, okay, let's think about metals, right? So you have a metal wire.
Yes.
Like the
that's good.
wire, and let's say the wire is one atom wide. So you have just atom
Yeah.
on atom on atom on atom.
That's the
when you-
simplest way. Yeah. To
Sure.
look at it.
So you hold the wire in midair, and there's no current flowing in it. There's no electron flowing. It doesn't have a magnetic field. And then when you connect it into a circuit and you close the switch,
Yep.
then all of a sudden you have these mysterious effects that arrive. And
That's
this is
right.
actually what's really interesting, is because I don't know if you guys saw, there was a video a couple of years ago now, Veritasium put it out, where he was like, what happens if you have an electric circuit whose perimeter is 1 light year, but the distance between the two sides of the wire is actually very, very small. It's like some tiny fraction of the light year,
Of course.
or I think it's like a light second. Let's not do a light year. And he's like, how soon does it take for you to observe current on the other side?
Right?
And it turns out that you actually, as soon as you close the switch, current travels through the wire, yes, and will close the circuit eventually.
Yeah.
But it begins also to grow out from the point on the other side of the wire and move through it in opposite directions. And so it's a motion that is transmitted through empty space to the other side of the wire, right? And so if it's a single atom thick wire, what we're saying is that the electrons or the atoms start to rotate.
The surface of the atoms.
The surface of the atoms begins to rotate in a cohesive motion. And there's hairs that are on the outside of the atoms, these extensions of the atoms, and those hairs sweep across the other side of the circuit, get those atoms to begin to move, and then that motion spreads out from where the terminals of the circuit are and travels through the entire thing until you hit an equilibrium point when everybody is moving the exact same way. And then once you have that, you have the stable magnetic field that is on the outside of a current carrying wire. Then you have the like stable vortex, so to speak, of electricity that is orthogonal to magnetism. Electric current in this direction, and then a magnetic field that sweeps around it.
You introduce another mystery.
All right.
So why electricity is 90 degree to magnetism, right? Yeah, that's another one. That's the Jacques Maxwell's equation tells us, right? But why is that? So there's a physical explanation. So you mentioned one very, very interesting. You said that each one wire, right? Each is by one atoms connected to each other, and you said that you connected in the circuit. and then you have an instantly motion. Is that right?
Well, I mean, it
Instantly
moves at the speed of transmission, which is
transmission. Yeah, which is about like 70% of the speed of light. Let's just say the best conducting material, right? And I believe we share one agreement, common things. You do not believe electricity is the flow of electron, do you?
Well, I don't think anybody really does. I
Well,
mean,
electron is a concept, and we don't believe in moving concepts around is the thing, right? So the
That's
electron
that's we
represents...
share. That's current electrical engineering textbook talking about the first thing. Electricity is a flow of particles, right? Flow of electron particles. So physical particles can directly go through, say, in this case, wire is a one atom thick, right? Just one atom thick, the wire. Electrons like traveling at almost 70% of speed light go through that atoms. That either go through the center of atom, or go through the surface of atom. So that's what the current theory is, which I believe is wrong. Yeah.
well, I think that they recognize that it's wrong because they're like, well, they're actually much slower. Like they recognize that the electrons in the circuit bump along at the speed
So
of a garden.
how much they recognize? So they recognize that there are still have a particle traveling, just not at that angle, not at that speed, or
They
not that
have
size.
this- the way that they deal with it is they're basically like, look, there's enough stiffness in the electron gas that as soon as you close the wire, the electrons that come out one end are not the same electrons that go out. They're not like, if you're at the positive terminal, the electron that moves very slowly is not the same electron that arrives at the negative terminal.
So
It's
hyping.
that they get bumped, right?
So when electron hyping to the other one, bumping the other one, have another
Yeah, I
electron
mean,
bumping that one.
I think anybody who's spent any time thinking about it realizes that it's a cobbled together approach that they're trying to fix a deep incompatibility in the theory. But it's like one of those things where it's like, it's like when somebody farts, you don't point it out in public. You just kind of keep
Right,
talking.
we never resolve it because the entire definition of electricity is wrong. It says flow of electron means implied. We have a particles flow from there. You just mentioned about maybe not the same electron, right? Maybe not the same particle, but something's flowing there, right?
But then if you really tear it apart, then you realize that the particle is not a physical object, and so none of these problems are even a problem because it started off with the assumption that you're moving these ideas around.
Yeah.
David,
Right? So
I
if the
hope you
electron is
hear
actually
that,
in
right?
motion to begin with, then what you're talking about is the flow of current, really, which is this propagation of motion from one atom to the next. And that's a far less paradoxical situation than
Yes.
trying to move these, what ordinary people think of as little grains of dust through a wire. It's not
So
quite
actually-
like that.
Mike, actually, you find the answer. The answer is no particle flow through the wire. It is what you just mentioned about it. It is a vibration. It's a wave motion. It's a vibration motion propagates because everything contact. You studied water molecule elasticity, right? That's where elasticity fall in there. Because of the elasticity, any or we'll call those oscillation or vibration. So this is truly electricity is oscillation of the particle. And then that's wave propagation. So that's where it is electricity, is true electricity what happening. The so-called flow of electron, that's a wrong concept. Let me explain further why I said it's a wrong concept. What I find is there is no, in order you have an electron flow, you have to have an electron inside of an atom. Am I right? You have to have an electron inside the atom. And the electron inside the atom have to have a motion. You have to assume electrons inside the atom and the electron have a motion. So then you somehow make that motion, you transfer that motion energy and start the flow along the wires. They said, on the surface or something. You have to make that many assumptions. That's all now have. What I find, there in an atom, one atom, there is no orbitals, orbits, or whatever, clouds, or electron distribution field. None of them exist. There is no free rotation. If there's no orbit, that means there is no free rotating particle whatsoever in the atom. So that's what I believe. We got the atoms wrong. So now I think you guys mentioned about everything started with atom, right? So now I said the problem is deeper than atom itself. The atom itself have no particle in rotation. There's no space between called principal orbitals or something. Yeah, as the board defined of the quantum orbits. So that's completely misled. The real atom. The real atom is just like a magnetic box. Let me show you. Let's use this one as a real atom. There is no over distance like a quantum principal orbit somewhere and have electrons orbit that one. So that I found that's something. It's fundamentally we defined that this is Niels Bohr's model is wrong. So if you are assuming that, let's assume that's right. Just like a planetary, solar planetary atom model, you do have a different electrons at different orbital rotating. You know why it has to rotating? If it's not rotating, because the nucleus in the middle have a positive charge, and the electron has a negative charge. If not rotating, what happens? The electromagnetic attraction, right? Gonna make them in contact. So that's gonna create called matter antimatter catastrophe. So that means what happened? So energy dissipated. Matter disappeared, becomes energy. Those are regarded as concept. But anyway, so because we are not allowed current theory, atom theory, not allowed the electron and the nucleus in contact because matter, antimatter. So then we have to keep, in order for this model to exist, so we have to have a rotating electron. If not rotating, it attract. Keep rotating is rotating, create called a centrifugal force, right? Centrifugal force. So, and the counterbalance of electromagnetic attraction. So that's why Niels Bohr said, hey, because we have this called a single charge particle, positive charged nucleus and negative charged electron. So that's why we have to have this complete rotation model. And this is where I am challenging about. If this model exists, so that would make every single atom to be a perpetual motion machine. As a physics, the first fundamental principle we know, there are no perpetual motion machine. Every energy could be dissipated, especially you have a revolving motion. So this is an accelerated motion, right? Whenever circular motion is an accelerated motion, you have to have a force pushing them, just like a magnet pull them. So this is you have a force pulling them, accelerated motion. If you have this motion, acceleration motion, it's self-dissipate energy. So if you consider every atom, how could the atom can exist constant rotation, never stop? We know atom probably is the most stable structure in the universe right now, right? So that's why we use atomic clock, because it can last forever and almost never change the property. So that's why we use an atomic clock. So where comes the energy to keep every single atom has different orbitals of electrons constantly in motion, which make and every single atom is a perpetual motion machine. So I thought that this is wrong. But why we made this wrong, that's what I tried to say that from the Coulomb's law, imply charge carried by two different particles. What I really try to say is, that's my discovery. Every single particle has both positive and negative charge. They are inseparable. So by that definition, the so-called electron we discovered is not a negative charged particle. It is physical particle. We all know it since I told them during that podcast. I told them everybody older than 3 years old, you should know this particle. A particle carry both positive and the negative charge. One particle. I asked you on the show, I said, I want to ask the audience, say, do you know which particles? It carry both positive and negative charge particle. And we all know it. One audience wrote a comment, magnet. So what I come all around to try to tell you one thing, electron is not a negative charge particle. It's a magnet particle.
I think we see it really similarly in that we see the atom as a magnet, essentially. And
Yes.
the electron is just the outer surface of the atom.
Electron is a part of subatomic particle, right? You can.
It's not a thing. Like we gotta be really careful. Like an electron is like an idea. It's not a physical object.
Like anything that can only be defined as being in motion is not a static object. Like if your definition includes motion, if your definition includes momentum,
Yes.
it's like saying that like I don't know, a car is only the thing that's the flow of traffic on the highway. It's
Yes.
like no, that's not what a car is. That's a car in motion. A car is a thing that has a structure that can be described when still. What you're describing what people are describing when they say electron is they're talking about traffic on the highway, and they're trying to treat traffic on the highway as being the car itself, and it's like no, like it's not, and that leads to enormous amounts of confusion. And so for us,
That's what that's what you're saying too, right, Doctor? You're saying that electron does not exist.
Oh, I mean, electron does not mean exist means electron as a negative charged particle. So does proton as a positive charged particle.
They're motions. They're motions
Does not
of atoms.
exist. Does not
No.
exist.
So motion occurs.
Okay.
Objects exist.
Yeah, we have to be
no.
careful with the word exist. It
Yeah.
can be really confusing. I mean,
Yes,
The
we
question
want
is-
to we got get it correct. Motion and the particle are two different things. Motion describe the particle's space, location versus time.
Yes.
In order to describe motion, you have to have a particle. Without the particle, without the carrier of the matter, there's no motion there. If there's no matter, there's no motion, right? So whenever we talk about motion just a characteristic, describe a location versus a time of some concrete object.
Yes.
So I want to differentiate. You know,
that's why this word particle is so broken, though, because the word particle in fundamental physics, it is not a physical object. It is a motion. It involves motion. Like it has a momentum. It's not a physical object. It's a motion.
You think about it. If it's not a particle, so that means it has no mass, zero mass. Can we see that one? Can we see
Which
that?
one?
Well,
The
the
mass,
atom has
even
mass.
no
I mean-
motion. And describe a motion. So we have to have a matter somewhere, right?
Well,
It's
mass is
completely-
another terribly confused idea, right? Because it is in some sense the way that we quantify gravity and inertia. But when we get to subatomic processes and we actually convert mass into its electrical counterpoint, the amount of effort necessary to deflect this column of ionized gas, essentially, inside of a vacuum tube or something like that. So it becomes something very different when we get into these subatomic particle
That's
spaces.
one. So now let's forget about the mathematical concept. It's a mathematical concept. It's not a real particle.
But Dr. Yu, you're trying to redeem the word particle, and you're saying to get rid of it because it's too confused by the mathematicians.
Well, you
No,
can't have it both ways.
No.
You can have it. It either we either use the word the way that the mathematical physicists use it, or we come up with a new word to describe the material that's at the base of the motion.
That's right.
And so
Well,
that's
do
why
you
we
agree
try-
with that,
we-
Dr. Yu? You call your theory the universal particle theory,
Yes.
and he's saying, but that term means a mathematical concept, and you're talking about it in a physical sense, in a material sense.
That's the word hijacked by theoretical physics, but that's not the common definition of a particle. If you look at the dictionary, any particle is a part of a matter. A part of matter is containing some sort of a substance. So it's not purely concept. It has a physical property. It can
And we
resist
gave
motion.
them, we let them have a particle. We were basically like, you want particle, take particle.
Yeah, we
It's
let the
fine.
mathematical physicists keep it.
Okay.
We use the
Yeah,
word
let them
fiber
use it.
instead
So do you
because
have
they
a
haven't
better term?
ruined that
A
version.
little.
They like the word fiber, right?
Oh, you want a fiber.
I
Fiber
like the
have
word
a
fiber because
capital.
nobody's ruined it yet, and everybody understands like all the other sciences. A fiber is something that has a structure, it occupies volume, it has a boundary that separates the outside from the inside. It essentially represents a unit of substance. And I feel like the mathematical physicists have ruined the word particle for all of eternity, and so we personally avoid it. And so it gets very confusing even in this conversation because we've all agreed that this word particle is not a mode of dust that everybody on the street thinks it is. And so that's why I think we're getting into...
Well, in Dr. Yu's world, it is a little mote of a dust, right? In that sense.
No, you know, that's where
It's a little magnetic dust, little tiny magnet.
You know, all this confusion is because of the fake theory of quantum is called the standard model of physics. Okay, the quantum theory. So that's all these concepts are confused by that one. So that's why, see, in quantum mechanics, even though we say that, you know, mathematics, we have to describe the particle, use a point particle. We have a point particle, you know, they define it a different way. If you now use a point particle, which is like a regular particle, so we don't have to avoid them. But let's just go back and say point particle. And then even though we mathematically describe quantum mechanics as a point particle, we still say point particle has a mass. So where comes the mass if it's just a point, have no volume?
It's more like an effective mass, right? It's the force equivalent deflection of a unit of gravitational inertia, something like that.
So if there is no, just think how could a single point interact or have an initial, interact with gravitational field if it does not have a matter?
Well, look. So I'm surprised that you point to Coulomb's law as being the place where physics fell apart, because I'm like, Newton kind of set this in motion by saying that gravity was action at a distance, hypothesis non fingo about the cause of gravity. And then, so like just before Newton was Descartes, and Descartes was like, vortices, man, there's the plenum, everything is filled with substance, everything is moving, and that motion is what gives us all of these apparent phenomena. And then Newton goes and he calculates it and he's like, that doesn't make any sense. It doesn't work out mathematically. I don't know what does make sense. And he gave up science at some point, right? He was always really into alchemy and he gives it up. He becomes this, he becomes an agent of the Royal Mint. And so he dresses up in costume and like goes to bars and tries to catch people in the act of passing counterfeit currency. And that's just kind of how his life ends, right? He's just like, screw this, I can't figure it out. Everybody tells him that he's literally the smartest person who's ever lived. The poets are writing poems about how Newton is brilliant. And Newton's like, I have no idea how this works. And then you fast forward and you get to Faraday. And Faraday is a chemist, and Faraday is working on electricity and magnetism, and he's the first. So Ørsted is the one that shows that the compass needle will deflect in the presence of a current-carrying wire, and then Faraday does all of the work to show like how electricity and magnetism actually relate to each other. But Faraday is a chemist who's working with this model of chemistry where atoms aren't little bowling balls. They're what's called point atoms. So there's this guy, Boscovich, I think Robert or Roger or something, and he's a theoretician, and he's trying to figure out why it is that you can't have two objects in the same place at the same time. And he's like, you know what it is? There's not actually anything at the location of the nucleus. What it is it's this mathematical point, and the mathematical point is surrounded by forces. And as you approach the center of these forces, the repulsive force goes to infinity. And so if two things, because they're trying to like figure out how to deal with atomic collisions with Newtonian physics, because they're like, okay, well, if atoms are indestructible, they also can't deform because they don't have subunits. And so at the moment of collision, the atoms have to be moving both forward and backwards, and that's impossible. And so he comes up with this force diagram. And by the time that Faraday and Davies are doing their chemistry work, they're using the Boscovich force atom, which has been modified to have not just this like infinite repulsion next to the nucleus, but it also has these kind of sinusoidal patterns of force that extend in all directions around the nucleus. And so they're using that to justify how chemistry occurs. They're like, if it was just forces, you can imagine that with enough heat and pressure, you could force any reaction to happen, but you can't. And so there must be some kind of compatibility between the resonances that's producing binding.
That's right.
And now when you look at particle physics, you realize that what they've done is they've taken the mathematical force particles of the atom and they've just shrunk them down to the subatomic particles. And so it's the same problem from Newton to Faraday to particle physics, where what they're talking about is they're talking about the detected behaviors.
Yes.
And they're reifying the detective behaviors into substance. But what we're really seeing is we're just seeing motions and actions and reactions of the fundamental substance that things are made out of. And like the atoms are made out of the same stuff as is doing the electricity and the magnetism and the bonding. It's just different organizations as far as we can tell.
I just want to make a clarification. When you're talking about the atom, is that the same atom as the Grace, Asian, the Grace philosopher talk about atom, or you're talking about the mathematical atom? Or what kind of atom you are, or quantum mechanics describe the atom has interior motions or something?
So like when Faraday's working, it is atomic theory is more or less a modification of Greek theory, which is that the atoms are indestructible objects.
Indestructible, and there's no substructure. Is that right?
And that's exactly what they treat particles as, right? So you have composite particles, and then you have fundamental particles.
That's
and
right.
The elementary particles are literally the exact same thing as the mathematical indestructible atom, just now subunits of the atom. And so we haven't actually clarified any of the, like I think that where we started was you were like, we don't understand atoms. And I'm like, yeah, it's crazy. Like physics operates in this space where they're doing all of this, particle detector stuff, where they're just like hitting things against each other and seeing motions. And instead of realizing that what they're seeing is motion that extends through the medium in the aftermath of a collision, they're treating them as objects that get spewed out from some atom in empty space. And I think we're on the exact same page about that. Like, I think we deeply agree with you about that. The specifics of like, how do the motions look? Is everything a magnet? Is it a particle or is it a fiber? Like these are, this is in some ways like ornamentation. They're like, it's details that fall out of a deep agreement, which is like, we have misconceived atoms terribly. We treat them as mathematical objects as opposed
Totally agree with you. We mistreated. We constructed the atom model cannot be existing in this universe. Atom has a planetary rotation type of atom. This kind of atom cannot stay on the test, say, with the conservation of energy. So everything is a perpetual motion machine. How could this kind of atom exist? So that's what I'm gonna just tell you what I discovered is there is no any motion part in the atom. So just like this kind of magnetic balls lumped together. And then there isn't, and the reason is without this one is because we defined called the electron, negative charge particle, because we got the electron wrong. I just tell you my theory, and you can see whether it makes sense to you. And how do we get the electron wrong? Is we assuming electron is single charged, negative charge, or protons positive charged particle. I name them as a mono charged particle. So because I find monocharged particle cannot exist in this universe. This is fun. I hope
there's a funny clip we did on radio years ago of Dr. Brian Greene on our show where Dr. Yu kept asking him if you could divide an electron, and it made Brian Greene very triggered, and he went to lecture the audience.
This is exactly. David just tell you the story. We interviewed Brian Greene years ago, right? At least pre-pandemic.
Brian Greene came off like a nun who was chastising a unruly student for asking a subversive question about how many angels can dance on the head of a pin or something. So that's what happened when he got triggered by that.
You guys, I consider you guys as a peers and as a very smart, high intelligent. So that's why I'm so excited. I want share my discovery with you. See if we can come up with consensus. The reason I found the so-called single charge or monocharged particle cannot exist is purely based on Coulomb's law. Of course, so let's say electron, no matter it's a physical concept, that's okay. It's abstract, does not contain any matter, that's fine. But it has a mass, right? So okay. So if electron, let's assuming electron is the object. I just picked up a circle. And this object, we know it has a mass because, we measured even neutrinos. Neutrino has a mass smaller than electrons, right? So we cannot say in this physical world, electron is the smallest particle, right? We cannot say that since we discover something is smaller. Okay, now my question is, see if it makes sense to you. Hypothetically, divide as two halves. Hypothetically, divide two halves. You said, well, physically, based on what is a Planck constant or something, certain small, you cannot divide. We are not physical divide, we are hypothetically divided. Can we do that one? Okay, conceptual divide. Okay. Conceptual divide. Then what do we get? We divide a negative charged electron. So do we get a 2/2 of negative charged electron? I find that this somehow is a logical conclusion. So only three choices. If you divide by a negative charged electron by half, either you have a 2/2 of a negative charged particle, or you have a 1/2 negative charged particle and 1/2 a positive charged particle, or you have a 2/2 all positive charged particle. Only three choices. So logical choice is you divide a negative charged particle, you should not come out with somehow smaller parts has a positive charged particle, right? Okay, let's assume you divide hypothetically, geometrically, not physically. Okay, geometrically, you make an electron smaller part. Can you put them back? Based on the Coulomb's law, if we have a like charge repel, that's Coulomb law, and which I consider that's correct and the fundamental physics law. If hypothetically electron subdivided as 2/2, and you cannot put together 2/2 because violate the fundamental law of electricity or magnetism. So that means like charge repel, opposite charge attract. Then if you cannot put them back together, how could this particle existed in the first place?
Well, I mean, our answer would be that the particle doesn't exist. It's a motion. It's an event. And so what you're saying is, if I destroy the event, what happens when I try to make the event happen again? And I'm like, have you heard of Prout's law?
I may not.
It's a really old idea that's probably been since like 1800s maybe. And there's a couple of people that are kind of still playing with it, but it's the idea that like everything is multiples of hydrogen, where it's like hydrogen just happens to be the most fundamental orientation of matter, right? It's like one positive, one negative, no neutron. It's just like the simplest structure. And then as you press hydrogens together in the great pressure at the center of stars, you start to get heavier and heavier and heavier elements because you're literally just squishing more hydrogens together.
That sounds like a foundation of chemistry right now. Yeah.
And
Yeah,
so,
he was a British chemist.
yeah, he was.
Yep.
And so it's
Sure.
like, I think that there's a lot of interesting thought experiments in like, okay, well, what happens when you break a hydrogen apart? What happens when you break a neutrino apart? Like, what is beta decay? Why do you get a proton, an electron, and like a little bit of extra squidgy energy? Like,
Right.
what are these things? But I think that the task of the next generation of physics is to come up with models that explain it. It's to
It's
see that
already
you
there.
actually- What's that?
Yes. Yeah, you said it come a next generation of model. I believe the model is already existing, and I'm trying to explain to you. I believe you come back to say, hey, it's not a particle, it's a motion. I try to define what is a particle and what's motion. Particle we define as a contain is a matter, is a contain is an amount of matter, and it has volume, it has mass. And I add one new things that which is absent from the history is there's magnetism. But let's just say particle has matter. That means has matter. So this is a particle. Now you said it's not a real particle. It's a motion. Whenever we talk of motion, is a description of the state of particles. That's what a motion is. So motion at which state, at which location of the time. So so motion cannot, during that conference, during this podcast, Terence Howard actually used this one. When I asked him what is the fundamental particle when electron, he tried to use motion, just like you said, use motion replace particle. I did not counter him, right? But because that was not, we are not addressing the same point. But just say motion is describe the state of the particle. You have to have particle, and then you have a motion. Motion is a time, is a function of space versus time of this mass. Yeah, I just want to make sure. I know you understand, but we may somehow you talking about the motion over real particle. I feel like that's what the Terence talking.
I want to kind of land the plane here, but I just the whole, just the general principle. It seems like there's a lot of common agreement here, and like you said, we're working out a lot of the details that are what was the word you used?
Ornamentation.
Ornamentation, like that. So you have the general principle. I think we're on to the same thing. The question is, are we using different language to get there, or maybe just different frameworks of thought? Dr. Yu's theory, there is no photon. It's just this magnetic medium. These infinitely divisible little magnets that construct everything. And so would you say, what was the proper word, that matter and force have always existed eternally? Is that what you believe? Am I using the right word there? Force? Would you say force or field have always existed?
Who are you asking?
I'm Dr. Yu.
Oh yes, yeah. I believe magnetism. Magnetism, you can say the dipole magnets, right?
So for Dr. Yu, in the beginning, there was always an existence.
Always existed as the
particle.
Fundamental.
So gravity is, what would you say? That is a
No. Gravity is just too small when you have a magnetism in a particle. Gravity, the strength of gravity is equals to what is it? So one charge of electrical force, just like a one electron force, and equals to 0. I'm sorry. Okay, let's say let's say one gravity. One charge of electron, and equals to 10 times 36 power of gravitational force. So that means gravity is so small. So that means 0 point. You have to put 36 zeros and then 1 times electron force. Yeah, that's a standard of physics. There's the physics have a definition of the strength difference, right? So that means the difference between electric force, if equivalent to 10 to the 36th power times of a gravitation force. So
The
that's the difference.
magnetic force is what binds galaxies together, in your view, right?
Yes.
And that's
But
why
what is,
that's
let me
why
just
they
be
have.
like, can I just be direct? Like, what is magnetism to you? Like, what is that? Is it just magic or what?
Yes, that's a good question. The origin of magnetism. The current theory says magnetism is due to spin or motion of electrons charge something. I said that there is no other charge than magnetic field. So
But
so-called the
what is
charge.
it? What is it? What makes the two
Magnetic
magnets?
force.
But what do
Just
you,
magnetic force.
that's the effect. Like, what causes the force?
Right now I can only say the cause is number one. The cause is not the any motion of a charge. There is no charge. The charge is so static electric field in my theory. Okay, static electric field just magnetic force, nothing else.
What generates the magnetic force?
Magnetic force naturally born. That's
So
something.
it's just there. Like there's no cause
Just
for
existed,
it. It's
just like a matter existed in the universe. We have a space-time and we have matter. And what I found is that every single matter has to have a magnetic force in order to manifest all the universe we have. Without that force, because gravity is too small, gravity cannot bind any two particles together.
And
Right.
so I think that where we probably differ quite significantly is that
Yes.
we're like forces need causes. To like in a theory, for me to be like I like that theory, there cannot be anything that doesn't have an explanation. Like so I would actually hold on, let me take one step back.
I could clarify that.
Go ahead.
Well, physical theories need physical actors that are acting out the dances that give rise to the forces that present themselves experimentally.
And so you're left with the question of like, why is there something rather than nothing? Like, why does anything exist in the first place? Like, that's kind of I don't think that there's an explanation for that. Like, I don't think that there is a Big Bang.
That becomes a religion's question.
Yeah, exactly. So like, let's leave it.
Yes, I know that. That's
Yeah.
you ask the key questions. That's right. I do not have. I know the origin of electrical charge. That's because from magnetic force. I know that one. I know the current theory turn around and say, hey, origin of charge or the magnetic moment is from motion of electric charge. I said that's wrong. Yeah, so that I can say that one. But if based on the current theory, so what's the origin of a charge? I don't think that they can explain them either, right? So in this case, I just say electric charge are magnetic force statically. Dynamic is moving magnets, that's a time varying magnetic field. That's called the electrical field. That's based on the James Clerk's Maxwell's equation, right? You know, yeah, that's the his equation. What is it? His third equation. You know, yeah, electro time change of a magnetic field. That's B, right? Partial derivative of the B versus the time give you what the electrical field, right?
I mean, I think this ultimately is a metaphysical question. It's like, for us, physics has to begin with physical objects acting out some play that it gives rise to the phenomena. If your metaphysics says that there can just be like disembodied forces that do stuff, then there's no amount of evidence or argumentation that will persuade you to come over to the other position. So it's like, we're not comfortable with disembodied forces having any sort of role in any physical theory without actors acting out the forces, but that's just our assumption about the universe, because that's the way our everyday world seems to work, right? There's no just forces.
I wish somebody can tell me what is the origin of magnetic force, which
so, I have good news. We are months away from publishing our book, where we will lay out all of this. It's called Paradox Lost.
Okay.
It will be all about our model of the material atom. We will explain light, electricity, magnetism, gravity as the function of atoms and motion.
So your smallest object is atom?
It's the fiber.
Oh, fiber.
Yeah.
Is fiber, so how does the fiber different than string?
In what sense?
Oh, string theory, smallest constituent is, so what's the difference? That's called a strand of energy. So what's your fiber?
Well, the fiber has architecture and structure that allows it to engage with other fibers and be displaced or enmeshed with other fibers. And so the atom and all of its rarefied filaments which link the atoms to their neighbors are constructed from the same fiber, which is entirely hypothetical. It might be monotonous, it might be homogeneous, it might be heterogeneous, there might be lots of different types of fiber. That's sort of what we use as the stand-in subunit for the atom and its extensions. But the goal of the project is to explain all these phenomena as motions of that fiber and particular motions of that fiber in structures of the atom itself.
Maybe I misunderstood you, but you're saying you guys reject the idea of a universe existing purely inherently as a disembodied force. You want an explanation as the creator, right? So you are talking about metaphysics, right?
Well, we're just saying, like, what is physics if it's not starts with physical objects? Like, if it doesn't start with a material body
he's saying all matter has always existed eternally, and it's always magnetic in its property.
Yeah, that's my.
And I would say that's not enough.
We're not arguing with that.
Yeah, I would say that's not enough for me. I would say I'm a Christian, so I would believe that there's a creator that's consciousness is imbued, and magnetism is a physical description of what that consciousness might look like, pervading in all particles.
Look, there's a lot happening besides physics in the universe. Like, exactly. If you need physics to describe the love you have for your wife, like, you've got problems. There's a lot of things happening that aren't physics. Like, physics is not the best approach to all of reality.
Right.
But if we're gonna do physics, then what the heck is it if it's not material bodies interacting with each other? Like, no spooky, weird stuff, no forces disembodied from reality, but like straight up material in motion.
And your argument is if you can't explain why matter has, in his view, fundamentally magnetic properties, then it's a just so theory. Is that what you're saying?
It's not that it's a just so theory, it's that the theory must explain it in order to be brought to completion.
In order to be physical, ultimately.
Yeah.
That would be a perfect
supernatural
condition.
Elements, right?
Yes. Does your fiber carry charges?
The motion of the fiber in organized structures produces charge, which is part of the atom. Like, we have a preliminary version of it worked out that addresses all of the questions that we had when we started on this project. And we're going to put it out into the world, and we want people to show us where it falls apart for them, to explain the pieces that are missing, because I don't think it's like a theory of everything. It's a way of taking what is apparent and trying to come up with some way that it hangs together in a way that makes more sense than equations.
Yes. I just make a prediction. So once you publish it, I hope people accept it, look at it, everything logical. But I would say, hey, your fiber is made by muons, the fundamental particle just connected, magnetically connected as fibers. So everything they approve you, I would say, hey, fiber made by muon particles with biomagnetic particles. That's what I would say. Yeah. So in your opinion, what substance made fiber? What's a fiber made of?
Probably more fiber.
Okay.
Right. It's a hypothesis. So like,
does every theory at some point have a just so, like one just so factor?
Yes,
because I believe in like a creator. So everybody's like, well, you just posited that to make everything fit. Well, everybody has one, right? Just so, right? You can't explain everything. Like,
what's a hypothesis? Like that's what a hypothesis is. You draw the boundary conditions on your theory. You don't explain everything all at once. You explain something, and you use a hypothesis to do it. It's like the fiber is the hypothesis. If the atom is constructed of subunits of some form or size, then their interactions should be sufficient to give rise to all of the atomic phenomena that we see. And so the motions are individually explaining the phenomena, but the fiber is just the hypothetical substance of the subunits of the atom itself. And so there's there's tremendous amounts of work to be done, even if this turns out to be a useful model for people, because we're not, like Nastia said, it's not a theory of everything. It's just a framework for approaching extant knowledge about the atom.
I just say that these are the things that need to happen. We need to have these conversations, and we need to find out what we agree with. I don't think you guys probably think much of the reigning theories, it sounds like. You're not a fan of probably dark matter and dark energy and all these things that are antimatter, all these classical kind of tropes of modern pop science views of physics, black holes. These are things that we, in my opinion, I don't find them to be very persuasive as existing. At some point, when you realize that a reigning paradigm has enough holes in it, there's enough anomalies that are just not able to be explained anywhere near accuracy by it, there needs to be kind of a coalition dialogue that comes along where people can present some common agreements about what we are saying is real and what's not real. And then, like you said, working out the details, the ornamentals. We can't put that, and I'm not saying anybody's doing that. I'm just saying in general, I think in the alternative science community that I've seen, like you said, everybody's always trying to say, I've got the final answer. And I've always told Dr. Yu truly believes he's figured it out. And I always say, look, I think he's got the best map I've seen. I want the best map because ultimately physics is a mental concept. It's a map to describe. It is not the thing. And the thing is what we're all living through reality. And to me, taking it back to the practical reality is we are living in an artificially dark age. We don't need to be there. And I believe that if we get a more accurate map, if Dr. Yu's map gets me much of where I need to see where the new world is, then I'm going to get on that. I'm going to get on my boat with that map and I'm going to go chart and head over to where I know I'm going to find something there. And maybe he didn't get one little div. I don't know. We'll see because we won't know until we know. But, that's kind of my practical approach to things is that his map is more accurate than any map I've seen so far. But I'd love to see other maps and see how I'd love to see, I love it when independent things confirm a similar pattern up the mountain or whatever. Like when I asked Dr. Yu, I said, what are some things that would be possible and theoretically if Yuan is the only particle and it makes up our body and therefore every particle in our body has a magnetic field and frequency and vibration and all these things. And I would ask him random questions like, well, what would you do with cancer if your theory is correct? And he said, I would take an antibiotic. And then he would explain the physics of how he saw antibiotics working in relation to the physics of a cancer cell. And then I found a guy independently who was doing just that. He stumbled onto using doxycycline and azithromycin to cure breast cancer and metastatic cancer stem cells dramatically. Dr. Michael Lasanti in Salford University. He hadn't seen his work, but it's just the example that when you're pursuing the truth, it tends to coalesce in certain directions. Another thing I asked him was, if your theory is correct, what's another thing? And he said you would be able to create elemental transmutation, without, taking elements. And then I find an independent guy named the late, great Dr. John Maluski. I don't know if you've ever heard of him, but he was a chemical engineer we got to know. And he's taking glass and turning it into gold and platinum, rhodium, and iridium using applied magnetic fields. Just like Dr. Yu predicted to me. He didn't know about John Maluski's work prior to me finding him because Dr. Yu was content to just have his theory. And I was like, I was dragging him to make predictions. No, you're going to give me just random things that I'll ask you and tell me if we could, and things like, nuclear fusion is never going to work. Hot thermonuclear fusion is never going to work, according to Dr. Yu. It would be some type of lower temperature, right? LENR type nuclear reactions would be something that we could pursue. These are things that we need to have on the table instead of allowing them to always be relegated to the fringe world, because the world is suffering from this just artificial level of scarcity of resources where we have to fight over mineral rights instead of creating new elements through trash. We could take trash and recycle them into rare earth elements without fighting over mineral rights. We could have, low temperature nuclear reactors powering our HOAs or whatever, our communities, without having to worry about a Fukushima level fear approach or having to pay the piper at the gas pump every day with these artificial wars. Or you could have, like you said, antibiotics or something else B vitamins, like my friend Dr. Georgie Dinkov, or Thomas Seyfried, who I know you guys have had on. He's been on our show since 2017. These are folks who are using the metabolic approach, which I think is downstream from something about what we're all talking about, and whether it's electromagnetism, or do you have a word for the fibers and the energy, or do you have a medium? Do you have a word for what's going on there with the dance?
Material atomics.
Material
atomics.
Okay. Is that the name of the theory, or the energy, or the life
It's not really
force?
a theory. It's just a framework for approaching interpretation of experiments.
Interesting. So what is like do you have a word for life force or whatever, energy, magnetic, electromagnetic, you said bioelectricity. Do you like that word, or?
I don't think that we do that. I mean, I think that we take the stuff that is apparent. Like there's metabolism. How do you explain metabolism? There's cancer. How do you explain cancer? It's like we're really careful to not be like, we have a theory. We're just like, I think we have a way of seeing things that might be helpful.
Right.
And that's really like where it begins and ends. And you said something that I think is so important and so accurate, which is that things have gone off the rails.
Mm-hmm.
I think we've mined out the paradigms that have worked for a long time, whether that's medicine or physics or chemistry or whatever else. And now we're in this intellectual foment where something has to replace the old ways of doing it. And something will win because it is the thing that lets us do the most. The same way that like mathematics won because mathematics let us do stuff on the basis of the equations. Right? It's like the whole of the Industrial Revolution is powered by a bunch of equations. Everything that we're doing right now is powered by the equations, and they worked. And I think that Dr. Yu, you're on the same tick as us, which is that, hey, perhaps there is some other way of conceptualizing things, of building mental models, of seeing things in the mind's eye that lets you accomplish something more than the math does. And so I feel very reassured that you're out there and you're working on it, and that there's tons of other people. And that's what we do at the podcast. Yeah. We have this conference in Portugal called Beyond the Big Bang, where we're doing it for astrophysics. We're writing this book. It's a massive project. Like the podcast is a tiny thread of the new vision we have for the world, which is countless minds, curious people trying to figure out what's next, what works better, what will get us to post-scarcity, what will allow us to have a world where nobody's hungry and nobody's cold and nobody's dying in wars. Like, let's get somewhere good. And the specifics of like, how the theory works is less important than does it get you down the road.
But it's the inciting incident, if you want to use that metaphor of the hero's journey, of like the inciting incident that shakes you out of your comfort zone to say, this is the matrix. I don't want to be here anymore. I don't care about black holes. I don't want to live in this artificially induced dark age. Get me out of here. And then that just like Dr. Yu had with his insight about what is light, and he starts going down this thought process, and then I see it, and I'm like, I've got to live in this artificially scarce economy that's designed to fail for the vast majority of human life within this system. We can't do this anymore. We're not going to be ruled by finance. We have to. And so in my view, I look at stories like with Jesus, feeding the fish and loaves to the 5,000 as a prophecy of what's going to happen in real life when people use nonviolent creative action, not petitioning the government or corporations to solve problems, but like you said, having these kind of, conversations. And then when you have, everybody always says, well, they kill all the people who do the great science, and they stole Nikola Tesla's documents. That's like this learned helpless mythology that we all have to never do anything bold or big, because it's like, well, if you go past that line, they'll arrest you and put you back in the prison system. It's like, that's a learned helplessness. And we can't let that mindset, control the way we think about this stuff. And I'm glad that you guys are doing this, because so few people, they tend to, OD on red pills once they take a couple of them, and they just go way, way into, La La Land, where, you're coming up with all kinds of strange things, or again, making conspiratorial fear mongering be the dominant. Well, there's nothing we can do to stop people who predate us because they will assassinate. Well, no, if you have like thousands of podcasts and live streamers and independent media covering the next Nikola Tesla type discovery or invention that's downstream from these dialogues that are filled with the truth, then it becomes harder to stop an idea, or like I like to say, it's no army can stop an incarnation whose time has come. Because it's not about the idea, it's about the incarnation of it, right? So we're gonna have 24/7 energy panels, right? And we're gonna have anti-gravity. That's what we're talking about, and that's what we're working on with some of our friends in our group. So I'm glad that you guys are doing that, and let's stay in touch, because our show has become kind of an information clearinghouse where there's a lot of stuff happening off the show. More, that's kind of the tip of the iceberg effect, where the show is the tip of the iceberg, and we're having a lot of fun behind the scenes with the folks that we get to meet. I appreciate you guys coming on. So people can go to what website if they're interested in your conference?
DemystifySci.com.
All right, and subscribe to
everywhere.
Demystify Sci on YouTube. You guys are not getting throttled or anything. We got obliterated for a while on YouTube. They had deleted my channel during COVID,
Oh wow.
so we had to go, but they brought it back.
Very nice.
Took off half the videos, but
Yeah, there's been some stuff.
There will be spies, there will be saboteurs, but ultimately the good guys always win. That's what I believe. So,
well, thank you guys for coming on. Dr. Yu, thanks for coming on.
Thank you. I just want the audience know we both share a lot of common agreement. We all see the mystified, this is called the mystery. We see a lot of unexplained mysteries existing in the physics. So that's how we all try to make it better to audience. So I like that demystify, that word. I sometimes use in my presentation. I call the unlocking mystery of universe something, and the demystify science. So thank you. I love our exchange of ideas.
Yeah, sure.
Hopefully we
Thank you
keep
so
in
much for
contact.
having us.
Take care.
yeah, thank you both.
Have a wonderful rest of your night.